increased angular spreadocyte too large of a drop of blood and looks faint, could be lower hemoglobin. So it looks, yeah, compared to this one, there may be, it cannot be lower hemoglobin because it didn't spread properly, or it has this, it is not tongue shaped also, it's spread. See this one, how it looks like, this one and the tongue shaped here, no streaks or anything, no feather edge, but this one has been probably sprayed too, did too much pressure with uniform pressure, that's why it's spreaded like this. What is this one? 7?
Too thin.
Too thin also, it didn't spread here. See, blood drop here also dried here, and it didn't spread here.
Like
So
too
that means the
fast.
pressure is, yeah. Spread slide too fast, decrease angle of spreader slide. That's I'm telling, decrease angle of spreader slide. That's why it went like this. And what is the another? Did not use the whole blood drop. Oh, that was actually didn't use the. You just put the slide and just go. 8 is the worst. 8 and 9 is the worst slide. What is 8? Obviously not inconsistent pressure. What do you think, 8? You guys have the answer. I know already. Spreader slide chipped at the end and has ends polished end. Yeah. So at the end, you can see maybe there is some break or something. That's why the when you are using the spreader slide, mind, with which you are spreading the blood slide, probably that slide was not clean. Sometimes it happen. You are doing smear one after another, and the from the blood drop from the other things it became dried here. Even it is not cracked, dried here, and then it becomes this type of stains. 9 is looks like a finger. Decrease angle. And 10. Blood drop, it's too small. It looks like thick. It's not too small. It didn't spread properly. Anyway, you guys learn it, and Asnet, you do this one, so then we can. Okay, so I'm going to go this one. Hopefully, it's going to come back.
I'll do that later.
Yeah. Just review it, and then it's going to come to me. Okay, so unit 4 and 5. We are going to go to the unit 4 and 5 overview. It doesn't English complete bulk overview. Just give me a second.
Something is wrong. Why?
So, Luis, are you there?
Are you calling me?
In the video. Let's come to video. What about Joanna?
Mom, I'm driving. I will open my video in a couple minutes. I'm arriving home right now. Just a moment.
Where do you went there? Where do you went? In the morning.
To drop off my niece at the daycare.
Wow. Responsible uncle, right? Yes. And Joanna, are you there?
Yes, ma'am, but I'm in the clinic right now.
Clinic? What happened to you? Are you okay?
Remember I think I messaged you on WhatsApp.
I didn't look at that. Sorry.
Oh, okay,
Yeah.
that's
Okay.
fine.
Okay.
Yeah,
Okay.
I just have like tonsillitis or something. It's really
Okay,
hard for
okay,
me to
okay.
swallow, so I have to go.
Okay. Okay. Because it doesn't come to me by name. So when it doesn't come to by me name, sometimes I okay.
Okay.
Okay, Joanna. Hopefully you'll feel better soon. And everybody become fit before next week because we have to do again. Okay. Yeah, every day morning is a problem for the. Okay. So so I can see Janada is there. This is the Janada. This is the Barna. Oh, Kara? Generally, you
I'm
can
here.
see you every day. Yeah,
No,
you
I
are
know I'm
hiding.
Oh, she's
Oh,
no, I'm
there
getting ready.
already.
yeah, because now I can see her head a little bit. Yeah, I can see the hand. Yeah. Okay.
Yeah. So I'm just
Yeah.
getting ready for my cardiologist appointment. So I'm here. I can hear you.
Cardiologist appointment for what,
Yeah.
Kara? Oh my God. Are you hope you are
For,
okay?
well, they're gonna do some an what do you call it? An echo, and then I have to wear a monitor for a bit.
Is that happened suddenly or it was there? You didn't tell me. So hope everything
No,
will be all right.
it started for now over a week. I had really bad palpitations and they don't stop.
Oh.
Yeah.
Oh. How is the heart rate? How is your what is called the pulse?
Fast. It's
Pul-
tacky.
Yeah.
Tacky.
How much? Tacky for sure. Yeah. How
I think
much?
when I was resting, it was like 116 or 118.
Even with the resting.
Yeah.
Are you in a lot of stress or something? Passing through some
That's
stress?
my whole life. That's my whole life.
You are a stress
So maybe,
lover?
yeah.
Or
So maybe
stress
my
comes
body's
to
just had enough.
or stress comes to you, or you are stress
It
lover?
comes to me. It finds me everywhere I go. Yeah.
Did you take any anti-anxiety medication?
Yes.
Oh, me too. Yeah. But it
Yeah.
gives me, yeah. Sorry to hear that. Hope everything will be all right. Okay.
Yes. Me too. Thank
Okay.
you.
Oh, I understand. When I had how is the blood pressure? Blood pressure is okay. Only the pulse or the blood pressure too?
My blood pressure is beautiful. Like perfect. It was
Oh,
113/70.
oh my God. Oh, that's good. Then it's fine. Blood pressure is good means your heart is fine. It's something is
Yeah.
some hormonal. I think some what is called stress hormone is releasing. That the
Yes.
adrenaline or adrenaline is giving you like that. Okay. Mine
Yeah.
has high blood pressure and then high tachycardia one time, and I have to be hospitalized. Yeah. Okay.
Yeah.
So yeah. Rugiato, are you okay? Looks like sleepy. Came back from work? I can't hear you, dear. Fix your microphone. I can't hear anything. No. You text me. I cannot hear you.
I cannot hear you.
Can you say now?
Yeah, I have to log in with my phone. I don't know what's wrong with my computer.
Now I can hear
Sometimes,
you.
yeah, because I log in with my phone.
From where did you get to Luis came? Sleepy.
Oh, no.
Oh. No, not you. Luis.
You can't hear me?
I can hear. Who is that? Rugato? I can hear you now. Huda, I cannot see Huda.
You
Huda,
can't hear me?
I can see now Huda's head is coming
I'm here,
up.
ma'am.
Like he's
I'm
coming
here.
from the sea. Some fish is, dolphin is coming up. Yusra, where are you? Okay, you are also doing
Okay,
like
let me.
this. Yes, yes. I like to see all my friends here. Okay, good. Okay, so yeah, then my days goes good if I see
Can you
everyone. What is Santiago?
can you
What is
can you
he? Oh, here is Santiago. Yeah, good, good, good. See?
I miss.
Okay. Yes. Why you are so deep in voice? The student dashboard. Let us do the student dashboard. What is the student dashboard? Dashboard. It's going to update. It's going to take me to the campus login again. What happened? He's still sleeping? Not found. What not found? Why is not coming here? I have to go to the student dashboard again. Uh, proceed to my home page. Yeah. It's so upsetting to every day you have to do the login. And from where this one came? Okay. Dear hematology, enter.
Okay, so good.
Who was absent today? Yesterday? Tell me the truth. Today is 7th? Yes. Today everybody is present. Okay. Yesterday who absent? Who was absent? Hmm? Can you tell me, dear? Somebody was absent. Who was absent? Because it shows 19 yesterday. People. It didn't show 20. And yeah, let us go to the team now. Okay, so this one is this one. This one is join the meeting. Okay, so this one is going to go there. Okay, so here, click it. Unit 4 and 4. Okay, 4 and 4, unit 4. What is the overview? Okay, so this overview is going to give you what you are going to learn from here and watch the Big Man Analyzer automation video and then review CBC test reference table. That is going to be the unit 4 and 5. Okay, student task. Okay, so we are going to do the student task later. After we do this one, let me go this one overview. Okay. What are we going to learn here? We are going to learn the specimen criteria for rejection. You guys know already. You have did already lot in the class from the probably we are doing it for a long time. So then list the component tests that make up the CBC. You guys know that. What are the component tests? Tell me what we can learn from the CBC before going there.
We will know all the morphology, the different conditions of the blood. If there will be some conditions like leukemia and anemia, ma'am.
What are the different
blood-
component parts, not the diseases? What are the
Uh,
component?
The
components?
RBCs,
Platelets,
red
blood cells,
and
white blood
platelets.
cells,
White
platelets.
blood cells.
What else?
Count, like
We have also the
differential.
reticulocyte, ma'am.
What else?
Hemoglobin,
Yes, come on. Then
Hematocrit.
Yes.
come on.
Sorry?
More.
WBC.
That's we told. WBC what type?
PCB.
Nope. WBC ACB. What is ACB?
PCB, ma'am.
Huh?
Oh,
PCB.
PCB.
PC.
PVC.
PCB. Back cell
PCB.
Oh
volume.
yeah,
Yes,
PCB.
back
Paxil
volume.
Yeah. What
Also the
else?
MCV, the mean
Okay.
corpuscular volume.
Okay.
And
Okay.
also the
MCSV.
ESR.
No, ES are not part of this test. ES are the different one. You
Yeah.
have to order the ES are differently. Yes.
The mean corpuscular hemoglobin content and the mean
Yeah.
corpuscular hemoglobin.
MCAC.
Yes, ma'am.
Differential.
Yeah.
differential white blood cells.
Yeah. So you have to know. That's why you call the routine blood test. I gave you the paper now. Did you remember that one?
Yes.
What
Yes,
are the
ma'am.
routine blood test means and where is that one? So there you
Yes.
can see what all the blood tests are. CBC can compose what. Then we give in the CBC tube what type of blood test we can draw. That is a different page and this is the different page. One page I give you the what is cardiac test means, what is CBC test means, what is liver function, what is the electrolytes, right? In one page when I give it to you.
Yes, ma'am.
Yeah. And
Yes.
and another page, how many you have seen that one? Looks like on the Evelyn and one or what is Christiana? Did I hear? Probably yeah, one or two are giving the answer. All looks like the very quiet, silent. It looks like I didn't give you anything. So in the other other sheet, I give each tube, color tube, and what type of test can be done.
Yes.
Yes.
Yes, ma'am.
Please go through that one
Yes,
too much.
miss.
Okay, just try to do that one. That is very important. Okay. And then it's going to tell what the component measuring, what the means, what if we mean measure hemoglobin or CBC, erythrocytes or leukocytes, principles of automated. This is we are going to come the automated analyzer here. Okay, what is the hemolysis? What is the sample? Ictric means, lipemic means, clotted means. This you all know which one you are going to accept, which one are not. Everything is there, right? And again, this is under the chapter 11 in your book. Where's the book? Pages 308 to 322. Okay. So CBC specimen blood collection. In general, the tube, except that is, I am telling you, sometimes in some labs you have the bigger tubes. But whatever they tell, you have to collect the volume because otherwise excess EDTA is going to cause RBC what? If you take the short draw, what is going to happen?
It
RBC
shrinks.
Shrinks.
Will shrink.
Okay. So in the CBC tube, it says it's a 4 ml tube, right? But minimum. That's why in the CBC tube, sometimes you doesn't need to fill the total tube. You can, if you can fill the 4 ml tube, it's fine, but the 4 ml is needed. Write this note. When you are ordering the ESR. If somebody ordered the ESR test, you have to fill the tube because you need minimum more than 1 ml tube, 1 ml blood, right? So you have to fill up minimum 3 ml or something like that. But for the only CBC test, it's a 4 ml tube, but you need minimum 1 ml. But 1 ml is good with the dilution. Okay? So you can ask me, it's a 4 ml tube. It says the marking up to this one. So if we don't fill it, then it's going to RBC shrinkage. Yes, they have been standardized in such a way that in 4 ml tube, if you can get 3.5 ml or 3 ml blood is fine. But sometimes there is a difficult patient, you cannot get the blood or the baby or something, or not the baby, I should say, the kid. So you may not get 3 ml or 4 ml blood, or the very skinny baby is not good to get the too much blood from the baby, or who is too anemic. So that time in the CBC tube, that is the criteria, is you have to have minimum 1 ml. That's why whenever you do in the collect in the lab, sometimes okay. So basically, that's why you need to feel. Sometimes when the class I said, okay, CBC, it's okay. Up to this volume is fine. So minimum 1 ml you have to draw it. Okay. So that is the minimum. Always, if you can fill the tube up to the fill marks is best. If not, for the CBC, that is 1 ml to run the test is fine. Need minimum 1 ml to run the test. Actually, you need 1 drop of blood to run the test, but in the autoanalyzer, you need 1 ml. In actual, when you used to do the hemocytometer or something, is a 1 drop of blood was enough. Underfilling change the anticoagulant blood ratio and can alter the morphology of the red cells that we already know, right? Next, mixing properly after collection avoids clotting. You guys already know that one. Always collect using CLSI order of draw. What is the order of draw? If you have ordered something, INR, or you've had some serum sample, you have ordered some plasma sample. So always follow the order of draw. Okay. So if I have ordered a routine blood work and an electrolyte panel and a fast GTT or fasting blood sugar, how is going to be the order of draw? Ying Hong.
Yes, ma'am.
Yes, tell me. You got a requisition where you have fasting blood sugar. You have to run some electrolytes. Okay. And you have to run a complete blood count. What is going to be the order of draw? How you are going to collect the tubes? What are the tubes in order?
For electrodes, it's light blue.
Electrolytes light blue? No.
Oh, sorry. CBC is lavender.
I want the order of draw. Excuse, yes, Luis? No, just give me a second. Just let me deal with Incheon, then I'm going to go back to you. Okay. So, Ying Hong, I don't,
Yes, ma'am.
yes, good. You know CBC is lavender, but I want the order of draw from the electrolytes, complete blood count, and fasting blood sugar. What do you think is going to be the order of draw? Order of draw means which tube you are going to collect first, and then second, third, fourth, whatever may be. Are you confident about that? You can answer, or I will ask someone to answer for you.
I'm just wondering for the electric, what tube is for electric? Then I know how the order of draw.
So what is going to be the order of draw? If I order, doctors ordered electrolytes, then doctor orders the CBC or complete blood profile and doctors has ordered the fasting blood sugar. So what is going to be, you have to write in your exam, they are going to give you all the options and they are going to give you the different blood testing and they are going to ask you in the order of draw in your theory exam as well as in our practical exam, there will be this type of thing. So you have to know which tube and then you have to let me know the order of draw.
The red, lavender, and the gray.
Lavender for what?
Lavender for CBC test.
And gray for?
Gray for the glucose testing.
Fasting blood sugar.
Fasting blood sugar.
And also doctor ordered some electrolytes. You are not going to draw the electrolytes?
Electrolytes is for a red top.
No.
Red.
No. So you have the confusion. Let Luis want to volunteer. Luis, can you just give the answer now? Be slow so that everybody can understand.
Can you repeat it one more time? So you have the complete blood
Electrolyte,
count, what else? The glucose?
fasting blood sugar. You have the
Right.
complete blood count with differential and you have the electrolytes.
Right. So you will start with the green tube, which is for electrolytes, followed by the lavender tube. With the green tube will also take your blood sugar together with electrolytes, and then the lavender tube for the blood count. Am I correct?
Yeah.
Or you can use the gray one after, but according
As
to the
per
new.
as per your exam thing and the fasting
Well,
blood
you will
sugar, you
yeah,
use the
you will
gray
use the
tube.
green.
Gray tube
You will
for
use
your all exams here in the written. You have to in the lab. You doesn't have to do that until it's the GTT or
right.
some But here, be careful for your exams
Then you
in
will use
theory.
the
Theory always pick up for blood sugar the gray tube.
Yeah.
And now if I order Luis and everyone in the class, Luis is answering. If I order the electrolytes here, though you can draw it in the green tube again for your exam in the theory again you have to draw it in the SST. Okay, so make sure whenever you are answering in your theory part of the exam, so you have to mark the SST. Okay, because till now not all over the world they have the finest auto analyzer.
So where you will use the SST tube
Yes,
for
yes.
the
Yellow.
Yes, yellow SST gold top tube for your theory.
Oh,
But
okay.
why I tell you all, because when you are going to in your practical field, so then because you see when there is a stat order in the emergency, they have to have a modern analyzer, because stat order means as soon as we can get the results in the plasma. So then we use the green tube, mean tube. But in general, all over the world, till maybe they doesn't have the finest or the modern auto analyzer. So till they are using the gold tub as in from the serum. There is no difference for the electrolytes. You can do it from the serum or you can do it from the plasma, depending upon what type of auto analyzer the lab is using. Okay. So, but for your theory, once again, theory part, when you are answering for the ML-POW, because still they are backdated. ML-POW, and for your theory, you can mark the SST for the electrolytes. Everyone is clear now?
Yes.
For
Yes,
me,
yes, ma'am.
Yes,
for
miss.
me, for me, the D12, till I'm telling you for the D12, if you write the green, I will give you the marks because I know. But when you are going to go to the ML-POW, it is out of my hand, but they prefer the SST. That's why I like to prepare you for the ML-POW also. Okay? D12, I have the chance because I know you guys know, and I know it can be drawn in the mean tube or in the gold tube or SST tube or the PST tube. Get
So,
very
Miss,
clear. Yes.
why do they make it so confusing? Why they don't stick to just one?
They cannot, because before you used to draw everything on the SST tube, okay? SST tube. The
Okay.
analyzer was not that updated or formulated or technically sound so that they can do from the plasma sample. The autoanalyzer that time before, it can only do from the serum. Now the autoanalyzer has the advanced autoanalyzer that I didn't make it, the company, because in the stat, because you can see SST tube, it needs minimum 30 to 40 minutes to stand to make the clot. Then you have to separate the serum to do the test. But in the plasma PST, the mean tube, 10 to 15 minutes standing is okay, and then you can separate the plasma. So you can do the test result fast when there is a need of stat, like the emergency, ICU, CCU, all these type of things. Okay, so that's why these are more advanced analyzer. Like every day before you used to use the CD, before you used to use the what is called CD for the computer. Now CD has gone. You are using the USB. After USB, you will see something. So like that, these things, the transformation more advanced.
So in
But
the MLT is the
it,
SST.
exactly. But you should have the knowledge why you do that. But there are some tests it cannot be done on the plasma, no matter what. Like the iron test, any type of anemia test, except the hemoglobin. TIBC, iron, vitamin 12. So all these tests needs to be done in the serum. That's why I have given you everything. Where some things electrolytes I wrote in the mean tube, and also I wrote in the SST tube. For D12, if you do the mistake, I will give you the marks because that is right. I can draw electrolytes. The lipid profile, you can do either in the mean tube or you can do in the SST tube in practice. But for your theory exam, you have to draw it in the SST. Until MLPOW has changed. But MLPOW cannot change everything because not each lab all over, they doesn't have the advanced analyzer, right? So then is going to be the confusion. Clear? Any
Yes.
question?
Yes, ma'am.
I have
Yes.
question, ma'am. I have question.
Yes.
This is Maurice. So every lab has different draw.
Not every lab. Not every lab. So maybe the Gamma Dynacar, if they have the one thing, all the collection centers are going to follow one tube. Light labs. So this depends upon the main lab, main core lab where the testings will be done, right? If the live lab in the Mississauga, for say example, or some head office in the Mississauga, or the core lab, we call the core lab. Okay, so then you have the collection centers, maybe here, this doctor's office, there may be 50, 60, 70 collection centers. They all are going to collect following the core lab instructions. If the core lab is advanced one, they will tell you can draw in the mint or gold.
Okay.
For the Gamma Center, like that, not each lab, they have, you give the guidelines depending upon what the core lab has. But now all hospitals mandated, they have to have the advanced autoanalyzer because you need the stat results. For the live lab, Gamma Dynacar, this is not any stat, right? They are going for the routine blood test. So till now, they didn't buy the advanced one. When their autoanalyzer has been broken or something, then maybe when they are buying, they are going to get the advanced one. You understand? They are not going to use a $1 million instrument. They are not going to throw it out. So they can use that one. So that is but sometimes the confusion comes. That's why you teach it. Some of you may be working in the hospital. Then you are going to tell, oh, teacher told me that for the electrolytes, it should be SST. Why you are drawing in the mean? Did we learn wrong?
Yes, that sometimes happened, Mom, that it's different from in the actual and in the theory.
Yeah. So no, applied is going on through but theory cannot change immediately because they have till the using majority are till using the old analyzer, which is it's understandable, right? It's a huge amount of money they have to invest and everything. So they cannot throw it out. So they are going to, and there is nothing wrong to draw it in the SST tube. Only the time is taking more time. But the gamma Dynacare or the Lipson or this type of doctor, there are different nowadays. They can know it because they are blood work, not stat. You are going to collect in the collection center, then you are going to make the serum or something like that. Then the collection people will come, they will take it. It's not stat. But the hospital, the all test results need stat. So you have to use the minimum time to give the results. So that is the huge difference between the collection centers or general testing centers between versus the hospital.
Oh, okay. Thanks, Mom.
Yeah.
At least we have idea now that.
Yeah.
Thank
So
you.
why is the difference? Okay. So basically, that's why I'm telling you, sir, why is ceiling SST and PST? Yes. But for when you are doing the work in our lab, in the not to waste your blood, you can draw any one of the tube. But you have to keep it in the memory and write it in the note. For any theory purpose, for ML purpose, you are going to do the SST. When you go to in professional field in practice, they will tell you because what you have to draw it. You can see nowadays the label is telling what you are going to draw because that is connected. Their LI system, lab information system, from the live lab is going to give you the guideline. You saw the label, right? I show you. They're writing the CBC, the lavender tube, mint tube. Remember I showed you the label, blood work label.
Yes, yes,
Yes,
Miss, you
yes,
did.
ma'am.
When there's an INR is light blue, nowadays is wrote to us. If you need the difference, so each collection center or core lab or the organization have their own LIS system. How they set it up, you have to follow there. But the order of draw is not going to be changed all over the world. If they say that you have to collect the electrolytes in the SST tube, it's not like that you can collect the SST of the lavender. Order of draw is not going to be changed in the all over world. Whatever the tubes you are going to use, after selecting the tubes, you have to follow the order of draw. Everybody is clear?
Yes.
Understand?
Yes. Yeah.
Okay.
Yes, ma'am.
Yes,
Okay.
ma'am.
Yes, thank you.
Okay. Okay. So that you know, you have to, that's why I said this one. That's why it didn't say anything. It said always collect using CLSI order of draw. Test ASAP for optimal accuracy whenever possible. Always, if you can do the test immediate, that gives you the best result. But in the collection centers, it's not possible. Sometimes it takes 2 hours, 3 hours, 4 hours, and then you have to preserve the sample as per that. That's why it is the time, how long the urine can stay in the room temperature, how long the serum after, how long the blood can stay outside, how long it takes, you can have to make the serum within which time frame. It takes 30 to 40 minutes to clot the blood to make the serum, but within which time frame you have to separate the serum, that is within the 2 hours. After separating the serum and aliquoted, that serum can stay. Before that, there is a change now. Before it was like that, it can stay only 4 hours. Now recently it has been changed to 8 hours. You saw that one in your exam, right? It is 8 hours. So after, not inside the blood or in the tube, SST tube, when you are aliquating, you know how you have aliquated. You transfer the top serum part in another tube. That can stay up to 8 hours. So each one is changing and we have to follow the rules. So then if refrigerated, allow to warm up the room temperature for about 30 minutes before testing. Anything is better if it takes long time to put in the refrigerator. Even is say 8 hours for the serum. But if it is my sample, I am going to say no. If it is within 2 hours, if it doesn't work, I am going to put in the refrigerator. It's my view from the research perspective. But now they still you can keep it in the 8 hours. So, but any sample, whether it's a CBC sample, what is the Gray sample, what is the any tube, if you cannot do it, or you have to wait for the collection, you have to refrigerate it. Refrigerate means 2 to 4 degree, lab temp 2 to 8 degree, the average temperature, base set temperature is 4 degree. But if you put them in the refrigerator, especially the CBC or tubes, any tubes which can make the plasma where the cells are suspended, you have to warm it. Anything like the blood grouping, even it's not the cell, you are taking it out. You cannot do it immediately. You need to put it 30 minutes so that it can reach the room temperature. It takes to 30 minutes to reach the room temperature. What is average room temperature for us?
20 degrees centigrade.
No, 23. 20 is cool.
Oh,
23
okay.
to 25. Okay. So that
Okay.
is the set lab room temperature. Okay. And now after you keep in the room temperature, are you going to do immediately? How you are going to do that? Before, what's the other step you are going to do? If you leave the standard tubes for some times, what you are going to do? You have to shake the tube. For anything, you can either put in the rotor or any type, for any type of CBC, blood testing, anything, or whatever the, even for the INR, plasma tubes, forget it, we are going to separate the plasma. For the group and reserve tube, for the INR tube, whenever you are going to do, you have to, before doing any test, you have to invert it couple of times. For what? Why we invert or mix the tube?
Yeah.
Why?
Even suspension and
Even distribution of
that's right.
components. Even
Yeah.
distribution of the component. Okay. So now processing and testing of the specimen. When a collected specimen stands for a time, the components settle into 3 distinct layers. Top layer is plasma, middle layer is buffy coat, a grayish white cellular layer composed of WBC and platelets, and bottom layer RBC. You guys know that one. This is why you need to mix EDTA tubes well prior to loading to an analyzer or for doing any test, whether you are doing the hematocrit, whether you are the smearing, whether you are doing the blood count, anything, anything. You have to mix the tube. Appearance of the specimen. You have to look for the appearance of the specimen. Look for clots. Why? We are going to come that. If there is a clot, it's not going to give you the proper result. It may give you less. Hemolysis. What should this means in vivo or in vitro? In vivo, what that means in vivo or in vitro? Anybody has any idea what is in vivo means? What is in vivo? I told you before.
In vivo is inside our body,
Inside and outside.
Yeah,
inside our body.
in vivo is within the body and vitro is outside the body. Why are they are telling in hemolysis? What would mean in vivo or vitro? So that whenever you collected the cells, if something's hemolysis, to check whether hemolysis is going on as a disease inside the body of a patient, or in vitro means your collection error. When you are collecting in the blood, if it's too jerk, it shakes, so sometimes it the hemolysis. So what is the reason? Whether this is really disease problem or the patient health problem or is a collection problem. That is very important. Unsuitable hematologic specimen like wrong tube, low volume, it's less than 1 ml, low volume, wrong tube. Say maybe in the plasma tube by chance they collected in the CBC, but when they are putting the label, they made a mistake. They put the mint level on the CBC level. In mean tube by mistake. So when you are labeling the tubes, you have to be very careful. Here you doesn't have the specific label in the lab, you are writing and putting it. But when you saw the label, when there is a CBC label, you have to put the CBC label to the CBC tube. When there is a mean tube or electrolytes, you have to put the specific labels. Otherwise, wrong tube, wrong label, cancel. You guys know that layers of a normal blood in a tube with an anticoagulant. We have the plasma, we have the buffy coat, and we have the red blood cells. Again, what is their drawing is wrong. Why? Tell me.
Pink RBC, which is supposedly red, and gray plasma, which is supposedly yellow.
No, not the color. Tell me the other things.
The
the
ratio from plasma to red blood cells is
Yeah, the
Exactly.
ratio.
Yes.
Exactly. They did the just opposite. They did the opposite. Red blood cells, plasma. What is the percentage of the plasma in the whole blood?
55%.
55. So is that 55 here?
No,
No.
they're opposite.
Yeah, that's opposite. Not even opposite, not totally disproportionate. So RBC may be this one, Bapicut will be here, and plasma will be more. So this is your judgment, right? They are here showing you the what the different layers you can get it, but that's not that you can see now. You guys know. So from immediately from here you can understand the diagram is not right. And if it's okay, tell me one thing. That's good. So if you got this type of results, what you are going to predict?
High RBC count, ma'am.
Yes, yes. So that means the patient may have polycythemia vera.
That's right, ma'am.
Polycythemia or polycythemia vera if it is in the high altitude. Very good. Okay, now we are coming to the automated CBC analyzer. Excuse me, I never use the automated analyzer. So I am going to learn with you guys. So CBC history, it doesn't need that. Who invented it or something? Complete blood count. Oh my God. So let's see what are the components in the complete blood count and what is the range. So it is written here. Is a negative, so differential, WBC, how they count it in the automated analyzer. Okay, what they count? It count the WBC, it count the RBC, it count the hemoglobin, hematocrit, median corpuscle volume, MCH concentration, MCHC, platelet, red cell white. What is how much? So this is the size. Red cell white mean you remember we have yesterday and it's microcytosis, microcytes, macrocytes, normocytes. So this is the volume. We have learned the volume also. Like one is the size and another is the volume. So this can tell you everything. Platelet white, MPV is medium, platelet volume. These are all things. This is the mono basophil, reticulocyte, and everything. So they can count all of them. But which are we mainly you need to know WBC, RBC, hemoglobin, hematocrit, MCB, MCH, MCHC, platelet, differential of the WBCs. Yes, WBCs like the monocyte and everything. So they are going to like the monocyte, neutrophil, that is the highest one. The lymphocytes, next highest one, monocytes, eosinophil, basophil. Basophil is almost nil. And in regular blood cell, peripheral blood cells, you are not going to see the reticulocytes unless the patient has severe anemia. So these are the component you can get from the complete blood count, how the printouts come. Okay, so they are going to give you the normal range, and if there is abnormal value, they are going to show you the abnormal value. So they are going to be seen by the histogram, I guess. Yeah. So laboratory tests performed in the hematology laboratory. Let me bring down to 75% again. Include the following: counting the number of concentration of cell. What they does, they Number the concentration. How many? Concentration means how many cells are there. Number. It should not be concentration. It should be the number. Determining the relative distribution of various types of cell. How it distributed. Test to help diagnose and monitor treatment. What type of? You already know. I told you CBC, hemoglobin, hematocrit, RBC count with the morphology. That is the size, shape, volume. WBC count with differential means different types of WBCs and platelet estimate. What is called RBC indices? What can give you the indicate? Indices means from the RBC count, what type of indication you can get from all these complete blood count, hemoglobin, and morphology. Mean corpuscular volume, mean corpuscular hemoglobin. That is the mean. Mean means average. Mean corpuscular hemoglobin. Say one cell is big, one cell is small. It's not too much. So it's going to be the mean. If there are too much large cells, then the volume is going to be high. Obviously, which you are going to see the results. And MCAC, mean corpuscular hemoglobin concentration. And now a standard part of the routine automated CBC. So these are the indices. You saw so many things. You doesn't have to remember all of the things, but just remember CBC includes hemoglobin, hematocrit, RBC with the morphology, and WBC with the differential and platelet. How much platelet is there? Then what are the, you have to remember what are the RBC indices you can measure. So you can measure MCV, MCH, MCHC. That's three. Okay. Blood cell count. Counting the various cells, RBC, WBC, platelet found in blood is a fundamental procedure in the hematology laboratory. So blood cell counts means you have to count all these three types of cells. Electronic counting devices avoid human error, which is significant in manual cell counts. In manual cell counts, there may have, but what the expert, they doesn't make the, nowadays is said, but before who was really expert and doing that, they can do really good. But it's still said electronic counting because it's using some technique, and technique is uniform for every sample. So electronic counting devices avoid human error. That's why it's important now, which is significant in manual cell counts. And they're statistically more accurate because of sampling. These devices count many more cells than can be counted manually, because it's taking a huge field. Okay, modes of operation, primary mode. So when you are doing manually, you can count one by one. But when for the automated analyzer, you can use maximal samples aspirated and analyzed automatically from the primary tubes closed system. So from you have one CBC tube, if you need, you can use for hemoglobin, you can use for the CBC, you can use for the whatever the malaria testing if there is need. Okay, because from the same tube, if it is in the same department, hematology department, but if the tube has to go to the chemistry department, CBC tube, for what test? We said the CBC tube to the chemistry department.
It's BA1C, ma'am.
Exactly, hemoglobin A1C, because that only goes to the chemistry department, and for that you need a separate tube to draw. So if there is a blood work order requisition, you have the CBC and the hemoglobin 1C, then you have to draw two CBC tubes, one which is going for the CBC or any other test which goes to the hematology department, and another one, the hemoglobin AC, though you have to draw it in the CBC tube as it is measuring the glucose attached to the hemoglobin molecule. So that needs to go in the chemistry department. So then samples you have to mix manually and caps are removed. Patient information test are entered manually. That even their laboratory information system you have to enter manually either by scanning or typing, and each sample is run individually via the secondary aspiration mode. The hematology, When in plasma, the red blood cells in the isotonic solution. What is isotonic means? The inside and outside of the pressure is same. You remember we have talked about the osmosis, we have talked about the diffusion. Anyone remember that when you learn the chemistry?
Yes, ma'am.
Yes. So that is the thing. Cells are always adjusting the pressure, pH, that is the homeostasis is going on. So when in plasma, red cells are in isotonic solution, means the composition of the electrolytes or anything is same. The pressure, what the pressure gives, the water, whether thickness or thin. So it's called the isotonic solution. So when you are diluting any sample, you have to use the same isotonic solution from the outside. What is that? Our body plasma main composition is saline, is 0.85% saline. That is the isotonic. So you have to remember this one. What is the physiological solution range? In brain, 0.85% saline. Whenever we are giving that to rehydrate any patient, that's the main composition. Forget about the other things which is deficient, but the main fluid, when if you are giving the bolus or you have to rehydrate, you are basically giving a solution 0.85% saline. When you are getting the saline drip, means what is the concentration you are getting? 0.8%, 5%, because that is the your in vivo strength or concentration. What is saline? Saline is a sodium chloride solution. This is nothing else. Sodium chloride solution, 0.85% saline. So any diluent used to dilute blood for CBC testing must have the same ionic strength, which is the isotonic. What is the ionic strength concentration as the plasma? That is the solution is called physiologic solution or 0.85% saline. Questions come. What is the physiologic solution? What is the percentage? What is the isotonic solution means? What is the name of the physiological solution? What is saline? Saline is sodium chloride and the concentration is 0.85%. These are all should be noted. Okay, so now we are going to learn about the hypertonic, hypotonic, and isotonic. This all comes from the movement of the solvent. What is the solvent? Here is the saline or the water also. It is going to move inside and outside the cell. So when the water, you have too much water outside in the cell and is less concentrated inside the cell. Now the body has to do the homeostasis, right? You have to maintain the same level, isotonic level. Whatever is the isotonic level is now disrupted if there is a problem. So what is going to happen? The diluted plasma, the water or the liquid portion from the plasma, which concentration is less, or if I just say a very simple word, is very thin, is going to move inside the cell to make both inside and outside isotonic. That is always a tendency to make the same concentration inside and outside of the cell. So when there is a movement of the water from the outside of the cell, that means to the inside of the cell, what is going to happen? Cell is going to, volume is going to be more because cell has a specific elasticity. If the more water or more fluid is going, water is going inside the cell, one time it's going to what? Like the balloon is going to pop up. It's called the lyse. This is the in vivo hemolysis. Clear? Hypertonic
Yes.
movement of water from outside of the cell to inside of the cell, popping up the balloons is the hypertonic. Hypotonic is the opposite. When inside the cell is more diluted and outside is more thick, that is the hydrated, when you have the dehydration. So then what happened? The water is going to come out from inside the cell to the outside of the cell to make it isotonic. But that time when the more water is going to come out, what is going to happen? The cell is going to be shrink. It's called the crenation. And iso means same. There is no movement. Cells are fine, happy, outside is same, inside. In general, always there is an isotonic. When there is a little bit, they always do the movement, the diffusion or osmosis, active, passive diffusion. But when there is some disease condition, what happened, or you had too much dehydration due to the diarrhea or vomiting or other things, that time you need to rehydrate yourself. So that is the hypertonic, hypotonic, isotonic, okay? Okay, now see how it looks like. Hypertonic means water is going from inside to outside. From the, no, again they made a mistake.
I
See?
think from inside to outside.
See it? What is the difference? Hypotonic movement of water out of the cell. So it's going to crenate. So it's going to hypotonic. This one should be hypotonic. Water is going out from the cell to the out. So this is going to be the hypotonic. Hypotonic, net movement of water out of the cell in excess. The cell will crenate. So this should be the hypotonic. My God, what I'm going to go do with these people? Oh, they are giving all the wrong information.
Yes.
Just like in D2O, lots of mistakes.
And this is unit 4, and 5. Okay. Just give me this one. What's the heading? Complete blood count. HEMA complete blood count. Okay, so Asnet, you are asking something for the break. Right, Asnet? So this is the thing you can see. This should be hypotonic. So what is coming out from the cell? So it's going to be crenate. When there is no change, equal is the isotonic, and this should be the hypertonic. Water is coming inside the cell, so it becomes soil. And ultimately, if it is too much soiling, it's going to burst. Principles of automation. For the counting, it use the electrical impedance. Remember these two terminology. So many terms. What is the principle used for counting, cell counting in the automated analyzer? Electrical impedance. This question is going to come several times. And for optical detection, that is the light scattering. For the shape, size, and number of cell countings, electrical impedance, optical light scattering. That's all. This is too much. So what happens? Cell passes through an aperture. They are going to tell you cell passes through an aperture which current is flowing and cause changes in the electrical resistance that are counted as the voltage pulse. When the cells are passing through an aperture, that is the electricity. When it's passing through an aperture, it's getting the resistance. And that resistance is counted at the voltage pulse. That's all. You doesn't need to know all the same vacuum draws. This is important. Size of the pulse is directly proportional to the size of the cell. Cells is counted by the pulse. When there is a pulse, the cell, 1 pulse, 2 pulse, 3 pulse, 4 pulse. So how many pulse has been gone? That means that many number of cells. If there are 50 cells, there are 50 pulses, 50 cells. And then what is the strength of the pulse? The strength of the pulse is going to tell you the size of the cells. So that is still pulse counts the number of cells, and these pulses are directly proportional to the size of the cell. How they represent that one? With the histogram generated by the pulse. So how it looks like that one. Let me open it a little bit. Okay. So number of pulses generated is directly proportional to the number of cells being counted. The height of the pulse is directly proportional to the size of the cells. So this is the number. How many pulses are there? They are going to tell you the number of the cells. Height of the cell, these questions will come. That's why I'm telling is I am getting slow because only 21 in the 52 slides. But this is going to come. And the size, height of the pulse is directly proportional to the size of the cells. High pulse means cell size is bigger. 3 histograms can be generated, one for the WBC, one for the RBC, and one for the platelet. I cannot see anything, but they sell the automatic analyzer, RBC and WBC bus on the Beckman-Coulter blood count analyzer. So when they go through, in this case, RBC and the platelets are counted in the RBC bath on the left here, and WBC is counted here. And hemoglobin measurement is done in the WBC bath using cyano. This is also important. How they use, what method they use for hemoglobin count here. SAN-MET hemoglobin method. Write it down, please. These are all important. That's why I'm getting so slow here. Note. So hemoglobin has been counted in the auto analyzer using the SAN-MET hemoglobin method. You doesn't need to know whether WBC bath or RBC bath, but you have to know how they count it. What is the principle they use? They use the SAN-MET hemoglobin method to count the hemoglobin in the auto analyzer. So height of the pulse is going to represent the size of the cells. Number of pulse is going to give you the number of cells counting. What are the method used? Is method the electrical impedance.
Ma'am, question.
Yes.
So the Coulter counter goes to the principle of electrical impedance?
Yeah.
Thank you.
But then they are going to give you the question. The size of the pulse is, height of the pulse is directly proportional to the size of the cell, or the height of the pulse will give you the indication of the size of the cell.
Okay,
Number of pulses is going to give you the result, how many counted, how many cells are there. How the results are shown or implicated in the Costello counter? By the histogram. Hemoglobin is measured by the measure of SAN methemoglobin method. Okay. Okay. Let's just go for a break now. Even we cannot complete this one, we are going to go sometimes in the class also, because this is very important chapter. We are going to see, you need to learn very depth. Okay, go for break. Sorry
Thank
for the
you,
late.
Miss.
So sorry for the late,
Thank you,
but
Miss.
this is very important chapter and you have to learn it. Okay, go.
Thank you, Miss.
Okay.
Thank you.
Okay.
Thank you.
We're back when? 15 after? Or, when are we back? 30 minutes?
Yes,
30.
yes.
Thank you.
Okay.
Evelyn?
Yes, Annette.
Hi. For that blood review, how do you click on, because I click on it and there's a whole different page comes up to put in the right answer.
Oh, you mean the slides?
Yeah.
Yeah, no, ignore. You'd better do it on your notebook. That's what I did.
Notebook. Okay,
Yeah.
good. Makes sense.
And,
Because I was like,
yeah.
and then how does she get it though? How does Miss get it?
She said, because remember I told her there is no option to submit.
Yeah, there's none.
She might want us to send to her email and keep that as an attachment, maybe.
Okay, so
I'm
I'll do it
guessing.
on a separate
Yeah,
page.
just write because I don't know. She did not mention earlier. Remember we
I'll
went
do
for
that.
the review, right?
Yeah, I'll do that.
Yeah.
Thank you.
You're welcome. I'm trying to respond to your email.
Oh, no worries. Don't worry. Don't worry. Trust me.
I'll try to
I
help.
came in late. I came in late last night, and
Yeah.
I was able to do those homework. And I said, "Thank God!" And I went to my bed. Don't worry.
Yeah.
Yeah. Yeah. We'll talk later, though. Don't worry. No,
Okay.
you work later. Take care.
No worries. I'll do my best. I'm
No
here now.
problem.
Yeah.
Oh, we're all here now. All right. Later. Take care.
You too.
Okay, so everyone is back now? Alexia, Fasardo, Yusra, what is that? Amina, I can see. Amina, why you are using dark glass? Where you are? You are somewhere? You are outside? I can't hear you.
Yes, ma'am. I have an appointment, but I'm
You have an
still on
appointment?
class.
Yeah, from here, where? I am concerned about everyone's health. Everybody said appointment, appointment, appointment. So I should make a huge appointment list now, being the eldest. Okay.
I guess you are more healthier than us, ma'am.
Oh, no, dear, no. It's
Yes,
not like that.
for
I go
sure.
by my mental strength, that's all. I just go by my mental strength. One day when I'll break totally. Looks like that. Now knee is really huge concern. Alexia, where are you? Kara is still on break? Yeah. Alexia, I didn't see you. Kara, you are driving again?
Yes, I'm going to the appointment.
Oh, yeah, you told me you have the appointment. Okay. Take care. Please. Hamina, what you are eating? Nothing. You are outside. Okay, Rugiato is there. Janaida is there. Yeah, I know. But Alexia, I didn't hear from you. I see Rugiato. Side. Only one hand. Yeah. Alexia, I didn't hear from you. I can see only your wall. I sent you the message also. I didn't hear anything back from you. If I don't see you within 5 minutes, you are going to be absent because they are keeping eye and give me for couple of students. They give me a feedback to inform me because they are watching also. So they are giving some students regarding their attendance. So be careful, Alexia. Not everyone, couple of students. And they knows about that. Luis, you are done for your break. We have to go. Yes. You are sleeping? It looks like Luis came up from the bed. I know, I see you. But it looks like how you wake up in the front of the camera, it looks like you are sleeping. You are tired? Oh my God. Weak? Yeah. Everybody is sick. I'm sorry for you guys. That's what I'm telling. Being the eldest, I can have a huge major list of problems, health problems. So far, keep me safe. All your wishes. Okay, let us start. That is the warm up. So we have gone through up to this slide. Mic is on. This one is done. So we just measure the hemoglobin by the hemoglobin method. The height is going to give you the size of the cell, and pulse is going to give you the number of the cells counts. Okay, so they how the at the same time when they are using the electricity or electrical impedance or the signal, also they use the automated counter use some scanning principle. How they scan? Using the optical light source. What is called, the name is called the flow cytometer. What the optical light scanner principle? They use the flow cytometer. Cyto means cells, meter means count, flow means flow of light. So measure light scatter, how much light is passing through, forward to side. I am not going to go through all these things, it's very complicated. I am just going to focus what the questions will come. If you want me, I can go through in details, but it's too confusing. Measure light, forward, side, these primary method combination. It doesn't need, we doesn't need to need the whole structure of the automated. We just need to the principle, what they use. Yeah. So what happened? How it generates the electrical signal? This is not going to come in exchange, but the question, but it is just to know how we are selling that electrical impedance. What is that? How the electricity is generated. When a light is scattered, when a light is passing through something, then it transforms into a signal. That is the electrical signal. Light is also source of energy. From the light source is converted to the electrical signal, which comes in contact with a photodetector. That means which detects and give the histogram. That's all. So light has been converted to electrical signal, just which generates the electrical pulse or impedance. Okay, so now this slide is important and they are going to ask questions from that. There is a light scatter. Light scattered from forward angle. These are the, this one the thing. So this is the photodetector. Light is scanning from this side, that side. Laser beam has been used. This is the photodetector. There are two sides of photodetector, and light is coming from different angles. So just remember these things. When the light scatters from 0° angle, it gives you the cell volume. These questions come forward angle or 0° angle. Forward angle to light scatter or 0°, it gives you the help to measure the cell volume. And when the light is scattering from the side lateral scalar is called the 90 degrees, is measure the largest structure inside the cells, like the what type of nucleus, what is that's why in the WBC count they can understand whether they're segmented or there is a one big nucleus or this is the granules. So that way they cannot see the colors there. So they can, how they do the differential count. When we do the slide count manually, we can see the different colors because we are staining the slides. You can see which is a purple color, which is blue color, what is the big size of the nucleus, what the neutrophils are segmented, nucleus of the neutrophils are segmented, or is a band, is a basophil, basically no nucleus, or the lymphocyte is completely full of the nucleus. But here we are just giving the blood. And how they use the electrical signal and the light using the photodetector. That is the automated cell counter principle. So when its light scatters from forward angle, that is the 0°, it gives you the, helps you to measure the volume of the cell. That means the morphology, whether it's a big or small or something. But more important is when the light is scattered from the side, it's called the side lateral scatter, and it's a 90° angle. The light goes in the 90° angle. Okay, so it measures the last structure, what is inside the cell, which correlates with the internal cellular complexity. As I told you, different granules, size of the nucleus, whether segmented, is what type of shape is that, everything. Side light scanner gives you the inside cell structure complexity. So scatter measurements combine to identify different types of WBCs, and each cell population is demonstrated, plotted on a scattered plot diagram. So in general, when you give this one, give you the histogram, mainly the RBC, WBC platelet, but the differential counts is presented on a scattered plot diagram. See the slide 30. So where is the slide 30? This is the 77. So this is the very complex things, how it looks like. You guys can go through it. It's very complex. How the is going to show. This is called the scatter plot. This is called the histogram. Okay, this is the scattering the lights. So from there they can measure that one. How big or small is the inside the cellular complexity. So these are the histogram, and this is called the scatter plot. You can see the difference. So light is scattering, giving the points, how big or small of the size. Oh, I can go a little bit. And this is in kind of bar plot. So it's called the histogram. So WBC differential count is going to be plotted through the scattered plot. And histogram can tell you that the RBC, mainly RBC is going to present as a RBC and platelet. They present in the form of histogram. The WBC differential count, it gives you the scattered plot. Okay. So how it looks like, this is the differential counts in the scattered plot. So how the this color is going to be changing due to the light, because light has different types of lights is getting. So you are going to get the lymphocyte like this, monocyte like this, but it's scattering, the light is scattering, and it's give you the internal structure. You can see if you go more details, you can see the lymphocyte is full of nucleus here. Neutrophil, eosinophil is mainly all the granules. So from there they can understand this is a very small picture. So this is the WBC by basophil. So these are the basophil. It's a late. There is no basophil actually. WBC basophil, how it looks like. So hemoglobin measurement in the counter. for doing the hemoglobin measurement, what the automatic analyzer does, it lies because hemoglobin is inside the RBC. So you have to get exposed that one. What is the method they use? So inside the analyzer, the Beckman-Coulter analyzer, the RBC it lies in the WBC bath freeing hemoglobin. That's why hemoglobin is counted in the WBC bath, because for doing the WBC, measuring the WBC, you have to hemolyze the cells so that the cells are free of all the hemoglobin and RBCs. Because the RBC population is more there. So you have to lyse the RBC so that you can take out the RBC cells. Then it's going to expose the hemoglobin. So in the WBC bath, you are going to get the WBC count at the same time of hemoglobin, because you are lysing the cells for counting both WBC and the hemoglobin. The hemoglobin is converted to a stable pigment and measured at 525 nanometer. You doesn't need to remember the nanometer. The more pigment is absorbed, the higher the hemoglobin concentration in the sample. What is that method? We call it, it's called cyan methemoglobin method. So blood, you have to hemolyze this one, then it's become transferred chemically, ultimately cyan methemoglobin. So this is the, we are measuring actually the cyan methemoglobin to measure the total hemoglobin concentration in the automated counter. Okay, so what is the principle used? The cyan methemoglobin, which is I showed you before also. What is this one? The hemoglobin here. Okay. So it is done in the, that's why it said it is done in the, that time I didn't tell you, because WBC bath, because in the WBC also you have to hemolyze the cells. In the RBC there is no hemolysis because you have to count the RBC total, RBC and platelet. So RBC and platelet is counted in one bath, and WBC and the hemoglobin is counted in the WBC bath. So again, just to repeat, the Coulter analyzer or the automated analyzer, hemoglobin is determined using cyan methemoglobin method. And it is performed in the WBC bath using, what are the diluting Drapkins reagent is used to measure the hemoglobin following the lysing of the RBC and release of hemoglobin. So how you do that? What is the reagent you use for doing the hemoglobin measurement? Drapkins reagent. Where it is used is in the WBC bath. And how, what product we measure for the hemoglobin? Ultimate product, what is coming is the cyan methemoglobin. So hemoglobin in WBC bath, it is hemolyzed to release the hemoglobin. Then hemoglobin, we are using this one in the Drapkins reagent. So ultimately the Drapkins reagents convert the hemoglobin to cyan methemoglobin, which we do measurement using the colorimetric method, using the photodetector or the whatever in the analyzer. To avoid danger of using cyanide, other analyzer are using cyanide-free sodium lauryl sulfate. So cyanide is a poison, right? So sometimes what happens, instead of cyanide, they can use this one. SLS is called the sodium lauryl sulfate. What is that? It generally hemolyzes the cells. Reagent to lyse RBCs and WBCs in the sample. So in the Drapkins reagent, the main component is the cyanide. You have learned it before and you have given the in the questions also, cyanide. Drapkins reagent has the cyanide. Okay, so instead of Drapkins reagent in the cyanide, because cyanide is a poison, and also not only that, non-stop it is going to use, and it is going to, when you are cleaning the things, it may go contaminate in the environment, or you have to have a huge number of biohazard things or chemical. It's not biohazard, it's going to be, as well as it's going to be biohazard, and the because we are using the samples, right? So it's going to be the biohazard, including the chemical hazard. So to take care of that, so they are using the sodium lauryl sulfate. Both are responsible to lyse the RBC, to generate or release the hemoglobin as well as the different WBCs. Who doesn't need to know all these things? What is the CBC counting then? Only CBC counting, red blood cell count, white blood cell count, and platelet count. That is a complete blood cell counting. What is does? This is the huge chart. So here is the general hematology is going first. When the results come out, how it gives you first the WBC, total WBC count, and you give the reference range. 10 E9, 10 to the power 9 cells per liter. So you have to remember the unit as well as the reference range. It's below and above is going to give you the penia or cytosis. Okay, so either philia, cytosis in the WBC, when that is the granular cells, is going to be the philia or penia, and in case of what is the sites, is going to be cytosis, like monocytosis, like that. RBC, erythropoiesis, or there is ectopenia when there is a less. So this is the reference range you have to remember. What is the reference range? Gram per liter, but we sometimes we see the gram per deciliter. So it's going to be the 14 to 18. Hematocrit, MCV, MCH, these they are going to all come out as a printout. So these two, platelet, what is give you the RD, what is, okay, so this is the total white blood cell count from here. This is total blood cell count. Then it's going to give you the information regarding the RBC. What is going to give from the RBC? Hemoglobin, total RBC count, hematocrit, MCB, MCH, MCHC, and red cell white diameter. And the platelet and MPV, medium platelet volume, is going to give you the platelet information. In the differential, they are going to give lymphocytes, monocytes, neutrophils, eosinophils, basophils, lymphocytes. Again, this is they are going to give the same thing in terms of percentage and also in terms of per liter. So some of them can use the percentage. What is the percentage of the lymphocyte is present? Neutrophil isn't. Neutrophil is the highest number. Is the general reference is 50, the range is 45 to 70. So it is giving you the exact value, which is the good one, general, but this is the range. So not everyone has the same physiology. So they have to make a range, and not only everyone, in the whole worldwide, they have to make the reference range. So different countries, depending on the environmental condition, depending the global position, they have the different values. Some live in the high altitude, some in the low altitude. So they have a range 50 to 70. Say for example, neutrophil, and it's going to be the same thing for everyone. Lymphocytes 50 to 41, average normal is, this is called the reference range, and this is the expected value. Monocytes, everything is like that, and this is the per liter, how many cells. This is the percentage present, and this the count. This is the percentage, this is the count, how many are there. So red cell counts is expressed 10 to the power 12 per liter. Hemoglobin is expressed gram per liter. Hematocrit is mainly percentage. We did that. L by liter, generally we doesn't do that one. You can convert it, but it is the 100%, the 100. So it's generally we express this as a percent. Mean cell volume, MCV, femtomole per liter. You doesn't need to MCV. You have to remember MCV means mean cell volume. Mean cell hemoglobin, MCH. From here we can understand M for me, C for cell, H for hemoglobin. M for mean, C for cell, V for volume. Mean cell hemoglobin concentration, mean cell hemoglobin concentration gram per liter. RBC distribution, white, how much is percentage, and then the morphology. These are called the RBC incidence, as I told you before. This is the RBC count, this is the hemoglobin, this is the hematocrit. But what are the RBC incidence? These are the, they can give you the option MCV, hemoglobin, or RDW. Which one is going to give you the RBC indices? So you have to know all which is starting with the M, that will give you the, but it should be H or V. It's not the MCP or V. This one, MPV. MP is platelet, but when MC is related to the hemoglobin. Okay, be careful. RBC parameters. What are the number of number of RBCs? That is the hematocrit, which is the packed cell volume, hemoglobin, protein that carries oxygen to tissues, and RBC incidence. So we have already, how we are going to count the MCV. So you have the hematocrit value times 10 divided by number of RBC. That way you can get the MCV. These all are come as a calculated from the automatic analyzer, but they can ask you how. They are going to give you some value MCV and hematocrit. Then they may ask you to calculate the RBC, or they may give you the hematocrit value and RBC number and ask you to calculate the MCV. So MCV is hematocrit times 10 divided by RBC. And the reference range is 80 to 96 FL. F is femto, is per liter. Femtoliters. HC is hematocrit, is percent, and RBC is red cell count per liter. Number of cells per 10 to the power 12 per liter. Same thing, MCH, medial corpuscle hemoglobin, how you can calculate it? Medium. Hemoglobin, everything factor is 10 divided by RBC. MCV volume comes from the packed cell volume. So hematocrit gives us the packed cell volume times 10 by divided by number of RBC. Hemoglobin, MCH, median corpuscle hemoglobin, H hemoglobin. So we have the hemoglobin count times divided by number of RBC, and the reference rate is this one. One is the MCHC, that is you have the medial cell hemoglobin and then medium cell volume. So MCH divided by MCV times 100 is going to give you the MCHC. That is the average of both. So these are the reference range. MCV, this is the formula you can remember, is hematocrit divided by RBC. MCH is equal to hemoglobin divided by RBC, but they are already factor of 10 everywhere. But this one, hemoglobin divided by hematocrit. So medium hemoglobin, median corpuscle hemoglobin divided by medium corpuscle volume. Corpuscle means cell. So red cell distribution, you doesn't need this one, but just let us know this doesn't come count, whatever the formulas comes. So red cell distribution, however you are going to, distribution is going to tell you the distribution as per the size, degree of variability. This is called the red cell diameter or wide, how big or small and or normal. Where is the normocyte? It's a microcyte, it's a macrocyte. So ultimately anisocytosis is the size of the cell, right? So how it going to do that? Red red cell distribution wide percentage standard deviation of MCV divided means you doesn't need to know the formula, to be honest with you, but you have to remember red cell the distribution or white is called the, it's calculated in the percent. Reticulocyte. Reticulocyte, you guys know that is the immature blood cells or the mature blood cells almost. Mature reticulocytes has only the cytoplasmic RNA. Immature reticulocytes still have the nucleus. But when it's come to the peripheral circulation, they are mainly the mature reticulocytes which has only the cytoplasmic RNA. Okay, so normal erythropoiesis and reticulocytes. High reticulocytes is called the reticulocytosis. It's a clinical indication that the body is attempting to meet an increased need of RBC that you know already. Yesterday we had discussed about that. That means the body need more oxygen. If the body need more oxygen, it need more RBC. If more RBC means they are going to ask the reticulocytes to come and do transform from the reticulocyte to RBC, even in the peripheral blood. What is the clinical use for reticulocytes? Sometimes when there is too much anemia, sometimes they call for the reticulocytes. So follow-up therapy of anemia. The reference value is adult is 0.5 to 1.5% of circulating red blood cells. Newborn is little bit high because they are still the RBCs are forming. They need more and more day by day. Every the baby is becoming bigger and aged. WBC. They need the total count, relative count, absolute count. Okay, so absolute count is decimal per units. Relative count is in percentage, what I showed you, and total count is the total number of RBC that we have shown before. Okay, so neutrophils, lymphocytes, monocytes, eosinophil, basophils. Never let monkey see banana. Once again, so here you can see the better structure. See the lymphocyte. That structure is wrong. So neutrophils, it has the segmented nucleus. Monocytes is looks like this one. Okay, full of this one. And basophils has very dense granules. Eosinophil is only pinkish granules. And it has bilobe nucleus. Okay, eosinophil has bilobe. One is nucleus, one is called the bilobe nucleus. And this is kind of C-shaped or sometimes S-shaped in the basophil. So this is the percentage. Neutrophil has the highest percentage, more than 60%. Then you have the lymphocytes is average. You can see is 45 to 50%. Then is everything is going down almost in the same range. Basophil is lowest, monocyte is there. Eosinophil, basophil, monocytes, they are almost in the close range. So it is written here, basophil 0.5 to 1%, eosinophil 2 to 4%, lymphocyte 25 to 25 to 45%, and lymphocytes is the highest 50 to 70%. But the reference, the actual good value is 50%. The same thing, monocyte 3 to 8%. CBC analyzer reference range is going to give you all the things. RBC, the number 10 to the power 12 per liter. Reference range is 4.5 to 6.5 times 10 to the power 12 per liter. And when the result, if it is low or high, if it is 2.5 into 10 to the power 12 per liter, is called the critical value. Or if it is 10 or more than 6.5, it comes in the critical value. Same thing for male and female. Hemoglobin also same thing. It is less than 70, then is a critical. If it's high than 70, it's going to be too much high or too much less is going to be difficult. So, but more concerned about the less because it's going to come as a anemia. Hematocrit, everything if it is less than up is going to show as the critical value, and immediately when there is a critical value, the lab immediately informs the specific doctor, physician, that your patient has this critical value. That means you need to take immediate action. So these are the WBC for the same thing. It has loading the specimens in the CBC analyzer. How you are going to load it? This is rejected. Specimen integrity after test results. So see how you are going to load it in the integrator. So it's not going to come up and down on this and that. Maybe you have to use the same size of tube. Okay. Read label to see if test order. Same label. It is the label. CBC should go to the CBC. Correct tube. 4 ml or 6 ml unspan EDT. You are not, for the EDT tube, it's going to be mixed, not spinning. You can get other tubes like the mint or blue or group and reserve, the tall pink, the dark green. They all can be for the plasma also, but they can be also used as an anticoagulant. But they have to stand and separate to plasma or something, except the group and reserve, forget it. But for the CBC tube, always you have to do the unspun, rather mixed tube. Autoanalyzer will mix it. Correct tube volume either 4 ml or 6 ml. Low volume in sufficient quantity may still be able to run. Check for clot first. Can affect the morphology of the cell. If there is a clot, it may affect the morphology of the cell. Maybe it's not microcytosis. It's going to show you the microcytosis means the clot is there. Clot specimen, if clots in, do not run if there is any. So whenever the sample comes the CBC, you have to look if there is any clot or not. If it is not clotted, if the volume is okay, minimum 1 ml till you can run it. But if it is really less volume, then you cannot run it. It's less than 1 ml, it's hard to run. So if there is clot, no way. Even anyone requested, reject the sample. You can see from the CBC whether hemolyzed or not. It from mishandling a specimen, RBC count should be falsely decreased because hemolysis means RBC has been broken down. It has hemolysis, right? So if the you doesn't mix the tube properly, it can form the clot. When you are drawing the blood, if it is sex or vibrate, it can hemolyze. So from there, from the tube, you can understand from the top, the plasma is starting little bit reddish. So if there is hemolysis, you have to reject the sample. Lipemic specimens. A high MCHC would suggest the presence of an interfering specimen like lipid. So even from here you can understand. That's why you need to do the MCHC. How you do that? That is the ratio MCH by MCV. Storage of requirements for EDTA tube. Run, collect sample as soon as possible if kept at room temperature. Samples can be stored refrigerated, that is the 4 degrees centigrade, up to 12 hours before running. Return to room temperature before running. After testing, samples are stored in the fridge for 1 week. After 1 week, sample can be discarded appropriately in the yellow biohazard bag. CBC analyzer daily maintenance, check reagents, lots, expiry dates, levels. Labels mean how much it should be filled in the autoanalyzer. Check printer and paper, replace paper if needed, ensure the racks are clean and good to use. Clean probes, which is going to do the measurement. Empty the waste container, wipe down analyzer with distilled water, keeps dust down, run daily controls, follow lab protocol, manufacturer recommendation. Quality controls. 3 levels. How you are doing the quality control? 3 levels of controls are run at the start of each shift or every 8 hours. This is the question. When you are going to run the quality control for the CBC, either start of the each shift or every 8 hours. Monitor all CBC parameter tested on the analyzer, low, medium, high. What is the analyzer? Assume that when controls are within expected reference ranges, the analyzing is producing accurate and precise results for 8 hours, or if it is you didn't running, generally the shifts are in 8 hour, right? Or you have to do it every day if you are running less amount of sample. Controls are human blood, same as matrix as samples. These questions come from which we use. They are given to give you the options: human blood, sheep blood, monkey blood. So from where you are using the controls? Obviously, you are running the human samples. So you have to run the human sample as a control. Right? So these questions come. So quality control is from the human sample as a things. Quality controls check lot, expiry date of the control material. Controls are stored in the fridge and must be warm up 15 15 to 30 minutes prior to analysis. Mix the vials gently end to end and ensure the cell button is completely up of the button. So you have to do that. Out of the established range, then further action is required before running. If the controls are giving problem, you are not getting in the expected values, what you have to check the expiry date of the controls, or the somehow the control has been damaged or something, you have to use a new control. You have to talk to your supervisor. We just leave once again.
Have you ever tried counting sheep to get to sleep? Maybe next time you'll count the minuscule cells that make up your blood. No? Don't worry, there's many professionals that do that test each and every day, and it is anything but sleepy. The number of cells that make up the different parts of your blood are very important to your health. I'm Andrew Chapman, and today we're counting on your blood to keep us healthy here in the lab. I'm here with Marnie. She's the manager of Core Labs and Rapid Response. Now, Marnie, why is it called Core Labs?
So the Core Lab consists of very high volume routine testing, coagulation, hematology, biochemistry. But in this area, we also have some of our specialty areas that incorporates hematology and chemistry.
Now, how many samples do you think you have in the lab on average?
I can give you yearly volumes. We do about 6 million tests a year.
6 million tests?
Yeah.
Wow. Mm-hmm. And then how many samples and test tubes and things
So
do you have?
usually that's about 1.5 million tubes.
I'm here in the lab with Jamie Lynn. She's a medical laboratory technologist. Now, Jamie Lynn, what exactly are we counting when we say we're doing a complete blood count?
Well, when we do a complete blood count, basically we're measuring the different components of blood. These components can be broken down into white blood cells, red blood cells, and platelets.
So what do the results of this test tell us?
So basically, CBC, you just want to look at the overall health of an individual or a patient. What happens is if we see anything abnormal or anything that doesn't seem right, we'll order additional tests. And then if anything's critical, we'll call the doctors, we'll call the nurses, just so that the patient themselves can get the treatment that they need immediately.
So Jamie Lynn, how does the actual CBC happen?
I'll show you, come with me.
Great.
So once the analyzer's done analyzing the blood, it spits out all these parameters for us and results for us to analyze, basically. So this is where the technologist comes into play. We look at the results and we see if it's valid, if there's something abnormal, if there's something that needs further testing to be done. So if a sample is abnormal, we would then do further testing and we would make something called a blood film review. So basically we take the blood sample and we make a blood smear and we stain it. And then once it's done staining, we look at it underneath the microscope in a microscopy room. If you want to see what it looks like, I can bring you over and we can check it out.
Okay, let's go.
So this is the morphology room. So once slides come off the stainer, they come into here, and this is where we look at it underneath the microscope.
Okay.
So what we have here is an abnormal cell. It's actually one of the cancer cells that you would see in a leukemia patient. So one of the distinguishing features of a cancer cell is this little circle inside its nucleus. So this little circle is called a nucleoli. You'll see a lot of them, like prominent ones, in abnormal cells. And if you compare that to a normal cell wouldn't have any of these features. Once we're done with the report, the results get released to the doctor, and based on what we tell them, they'll treat the patients. After that, we just go to the next slide. That basically is the process from CBC to morphology.
Wow, amazing.
Yeah.
Thanks a lot, Jimmy.
No problem.
And thank you to the Laboratory Medicine program at UHN for letting us come in and learn. If you want to see more videos like this and learn more about what happens in the lab, please visit medlabprofessionals.ca.
Welcome to this video on interpreting the full blood count, designed to cover everything you need to know as a medical student, junior doctor, or anyone else wanting to understand the full blood count. By the end of this video, you'll know what each component of the full blood count means, what causes them to be abnormal, and how to correct abnormal results. Normal reference ranges will be shown later in the video. Full blood count essentially tests the cells in our blood, which can broadly be categorized into red blood cells, white blood cells, and platelets. Let's go through these one at a time, starting with the red blood cells. There are three measurements taken from red blood cells that we can interpret. Firstly, hemoglobin, which is the iron-containing protein found inside red cells that allows them to carry oxygen. When looking at the full blood count report, this can be high, meaning that patients have polycythemia, or it can be low, in anemia. Causes of polycythemia are polycythemia vera, which is a myeloproliferative disorder where the bone marrow produces excess red blood cells. This is rare but can be fatal if not treated. COPD can also increase hemoglobin, as patients are often hypoxic for prolonged periods of time. This induces erythropoietin release from the kidneys, which promotes red blood cell production in the bone marrow. Living at altitude will also increase hemoglobin, as will taking exogenous EPO, for example, in naughty professional cyclists. Polycythemia is bad, as it can be symptomatic for patients, for example, itching. But its most serious complication is blood clots. It's therefore an important condition to diagnose and manage. Long-term aspirin can be used to help reduce the risk of blood clotting. Venesection, or bloodletting, can be used to reduce the total volume of red cells present in the blood. Hydroxycarbamide is a specialist medication used to treat polycythemia vera. Anemia means low hemoglobin. When trying to decipher the cause, it's useful to also look at the mean cell volume. Depending on the MCV value, anemias can be categorized into microcytic, meaning small red cells, normocytic, meaning normal-sized red cells, or macrocytic, where the red cells are large. Each of these has different causes. Microcytic anemias are often caused by iron deficiency. This could be due to blood loss, celiac disease, or poor dietary intake. Anemia of inflammation is where a chronic inflammatory condition lowers hemoglobin over time. This can also cause a normocytic anemia. Thalassemia is an inherited condition where there is a reduction in the amount of hemoglobin produced. Normocytic anemia can be caused by myeloma, which is a bone marrow cancer that results in pancytopenia, meaning red cells, white cells, and platelets are all low. It can also be caused by acute blood loss and anemia of inflammation. Macrocytic anemias are linked with B12 and folate deficiency. Hemolysis, which is the degradation of red blood cells, This can be caused by infection, autoimmune hemolysis, or a condition called spherocytosis, where the red cells are spherical rather than concave-shaped. Chronic alcohol consumption and hypothyroidism can also cause macrocytic anemia. Most commonly, anemia will cause the patient to be short of breath, tired, have palpitations, and be pale. Management should be focused on the underlying cause of anemia. If severe enough, patients may also require a blood transfusion. We typically give blood transfusions when hemoglobin falls to 70 or below. Hematocrit is the third measurable component of red cells. This is the percentage of blood that is made up of red blood cells. It generally follows the same trend as hemoglobin. It can either be affected by the number of red blood cells or the volume of blood plasma. As part of the full blood count, we also have the white blood cell count and the white cell differential, made up of specific cells that make up the total white cell count. Leukocytosis is most commonly associated with infection, but it's not that specific, so can also be present with any ongoing inflammation, post-surgery, with steroid use, and in pregnancy. Leukopenia can be caused by hematinic deficiency, i.e. B12, folate, or iron. Bone marrow failure will cause leukopenia as part of a pancytopenia. This can have a range of causes, including acute leukemia, chemotherapy, and aplastic anemia. Sepsis and some medications can also reduce the white cell count. The white cell differential is often overlooked, but can be useful for identifying more specific disease. Generally, raised lymphocytes can be associated with viral infections, and raised neutrophils with bacterial infections. Basophils and eosinophils can be raised in atopy, for example, asthma or allergies. Eosinophils are also specific for some parasitic infections, like helminths. Finally, we have platelets. Thrombocytosis can be reactive, meaning the platelets will increase in response to infection or inflammation. We can also have essential thrombocythemia, which is another type of myeloproliferative disorder, and underlying malignancy. Thrombocytopenia can be caused by bone marrow failure, DIC, or immune thrombocytopenia, which is an autoimmune disease. If platelets are low enough, or if there is concurrent bleeding, the patient may require a platelet transfusion. However, it's important to be aware that transfusing platelets in a patient with immune thrombocytopenia will not be a good long-term solution, as the patient's own immune system will continue to destroy platelets. To summarize, the full blood count analyzes the red cells, white cells, and platelets, which make up the cellular components of our blood. There are various causes for high or low levels of these components, so a full blood count can help narrow your differentials and also monitor ongoing treatment. Please consider subscribing and liking the video. It helps my channel out a lot.
Okay, are you guys ready to do the exam tomorrow? For the A and P? In the afternoon, you can take the exam around 12. If you want to do the review, all the reviews and everything. Can you hear me?
No,
Yes,
miss.
yes.
Everybody's quiet. No.
We're shocked
We're
about the
not
exam.
ready. We're not ready, miss. Everybody's
We were
quiet.
all surprised,
We're
ma'am.
all surprised. It's a big surprise. I couldn't close my mouth. I'm like, what?
Yes.
What exactly?
No, then
We'll-
how we are going to, okay, so listen, one thing. If you want to do the exam on Monday, it's not easy because I have to book the computer lab again. This, you can do it at home. This one, not the final one, okay? So that's I'm telling. So if you want to do it on home, you can do that one tomorrow. Okay?
Okay, mom.
I'm telling you the options. If you have to want to do it next week, then we are in lab, right? So we have to be in the lab and do that. Then I have to book the computer lab again. Because next week we are in the lab. If you want to do the exam next week sometime. Or the another option is then following week we are going to be the online again, right?
Yes, ma'am.
So tomorrow I can start the next chapter, the homeostasis and other things. The following week we can give, I by this time when you are on the on campus, I can send you the review for the A and P and some reviews for the next two models. Okay, so next week, I'm not next week, following week you have to take the 3 exams. One is for A and P, one is for the next model, the homeostasis, and third is going to be final. Is that okay for you guys?
Wow.
It's going to be a lot.
A lot.
So tell me how you are going to do it. You give the option me. Tomorrow you can.
Yeah, that the unit.
What is that? What do you want to know?
I
40
mean,
questions.
yeah, if we take the exam tomorrow, it's just unit 1 to just unit 1.
One
No,
to
Ma'am?
five.
unit 4, I guess. No, 4, no, 5. What is that?
5.
What
I
you
Unit
did?
1 to 5.
Yeah.
Yeah.
I am
Yes,
giving.
that is
Okay,
right. That is right, Lois.
okay. I am giving you the option. That's why I ask you whether you can take the text tomorrow, right? So that's why I am giving you the option. You guys decide as a majority what you want to do, then I'm going to do that. So either you can take the exam tomorrow or next week if you want to do it in the lab, it's okay. Then I have to do it in Wednesday or Thursday. Or Tuesday, I'm talk to Vera when the computer lab is available. So you can go do the test, then we can start the lab. Okay, we can do the test, then we can start the remaining time we are going to do the lab. That is second option. Third option, we can start tomorrow the review from the other units, and then following that one, the third week, not third week, next following the next week when you are going to be online. So you have to complete the other sections and then you have to run the A and P unit 1 to 4 and then 4 to 6 or something, and there is a final exam. So now you guys tell me what is good for you. Generally, the no instructor said, other instructor will say, so this is done, you have to do the exam tomorrow. So I am giving you the, tell me you guys.
Yeah.
Miss,
No,
what's
I
gonna be
think
what's gonna be on the test tomorrow? Like what
yeah, for
units?
the review.
That is from the units what you have learned from 1 to 6 or whatever we learned today. 1 to 5.
No. I agree for tomorrow.
No, I can.
Yes,
Yeah.
No.
Raise your hand.
Yeah, we need to raise your hands if we are.
Miss,
Yes, I'm listening, dear.
are you gonna be sending out the review questions for tomorrow if we
Yeah,
decide?
that I can do that. That's I'm just telling.
Okay,
Oh
So
yeah, that's
if you're going to be sending out the review questions, and if we can take the first part of the morning to review, then the second part we can do the exam. I don't know what you guys think.
That's what I'm telling you.
I'm
Right
okay
now,
with
right
that.
now, right now, if I send it to you, guys have some time.
Yes.
Yes,
Even
ma'am.
I have to work. I have to look. No, you read it because I have to work on the review too, right? So
That's
we
fine.
yeah. So you guys
So
can
we'll
review.
read in the meantime, and
You can read in the meantime. Then I can send you the
I'll-
reviews. You have to work in the night or sometimes today, sometimes on the reviews.
Yeah.
Most of the answers
Okay.
are there, and then you will get some time in the morning also. So I'll just let me see how long is the things.
yeah,
Let
we'll
me
get it
see.
over and done with, because next week is going to be pile on, and the following week can pile.
Yes, that is right.
Yes, ma'am. Yeah, we're okay tomorrow.
Yeah, I'm okay
As
with
long
It's a
as
one.
we have the reviews.
It's 1 hour. Okay.
Yes, ma'am.
So
So
40 questions, I
so
guess.
you can start at 12, and then you can complete by 1. Before that, you can do the what is called reviews.
The reviews.
Okay.
Yes.
Yeah.
That
So
sounds
you
Okay,
guys
that's fine, ma'am.
okay. Listen, this review I am not going to give you any answer, right? This review you have to work on that before the final.
Yes.
I will go through the review as I do, because this is your learning time. You are going to be
Yeah.
here from 9. You are going to be, if there is 1 or 2 critical question is fine, but not every questions. This is you have to learn now. On the final, before the final exam, I will go for a review. Right? With the
Yes,
answers
ma'am.
and other things that we can do, because by this time you guys already learned that one. But remember, following the next week, you have to do the test number 2, and also maybe the final one. Maybe I can push it to the Monday, so that you can Friday you can do. We'll see if you can just complete the things by Tuesday. Then maybe you can take 1 test on Thursday, 1 test on Friday. Then you can complete the hematology. Okay, we'll see this one. So tomorrow, let us work for tomorrow. Okay. Okay.
Yes,
So let me work.
Yes, ma'am.
Yes.
Miss,
Yes.
I just don't want them to pile on each other. I don't want them to pile together. So it's better if we do them as we go.
I don't. I didn't understand, Asnath.
Like
What do you mean?
it's to me, it would be yes.
Yes.
The majority is okay. So I'm going to work on the review. I'm going to send it. You guys study now.
Okay.
Okay, ma'am.
Okay.
Thank you.
Yes.
Thank
You
you.
study, don't leave, study right now from the whatever.
Yes.
There is not too much expert. And probably I told you several times the same words, because this is very important. Okay. So just go on there. I am going to work on the reviews. And by the end, whenever I am done, I'm going to send you the reviews. You work on that. You have tomorrow morning also up to 12 with your break time. You have that. Even you doesn't need the break time. You can have your dinner, lunch, dinner, breakfast, whatever beside your table, and work on the reviews. And then from 12, you can do the exam for 1 hour. And then in the morning, make your breakfast and everything ready beside your table. Okay. And then you can start reviewing. Then do the exam at 12. 1, done. Tomorrow is Friday, right? Yeah. Okay. Is that
Okay,
okay?
ma'am.
Yes,
That
ma'am.
sounds
Thank
good.
you,
Yeah.
ma'am.
Yes.
Okay.
Thanks,
So
ma'am.
now I have to stop sharing, and I have, because I cannot, when I'm working for the reviews, I have to go back and forth. Okay. So I'm stop sharing, and then I'm going to send you. But till I am on team, I am listening, but you guys do that then. But I am going to concentrate on the review now. Okay.
Okay,
Okay.
ma'am.
Thank you.
Okay.
Thank you.
Thank
Okay.
you.
Okay.
Ma'am, minor question.
Yes.
Can I bother you?
Yes.
So regarding the because I have one. We're going to New Brunswick, ma'am.
When?
My classmates know now. That will be afternoon of the 25th, the Holy Week.
Till now, I doesn't
And
know.
I saw this our schedule, and we will be in campus starting next week.
So where you are going to be? Yeah, 20. No, you are going to be online, I guess.
On the 25th, ma'am?
Yeah, because 11 to 15. Right now we are on this page, right? 8.
Yes,
And the
ma'am.
next week we are going to be on campus up to 15th. And 18 to 22 we are going to be, yeah, you are right. 18, no, this is going to be online. And 25th we are going to be on the campus. Yes.
Yeah, so I'll be absent 3 days actually.
So that you need a special permission, because if you just absent for more than 2 days, then I
Yes,
have to
ma'am.
send an email to Brenton, and you can write and send an email, and I will forward it to the Fatima and Brenton. Okay.
Okay,
So
ma'am. Thank you.
if the students who are not in probation or something, any problem that is before, it's okay.
Yeah.
You can take it, but you have to inform me, and I will send it to there for the reason. What is the reason or something? You can write it down. Don't write
Yes,
you are
ma'am.
going to visit the family or friends. Write something. Okay. You need to go there. That's why. That's why I
Yes,
can give
ma'am.
you the suggestion.
Okay,
Yeah.
ma'am. Thank you.
Okay.
Ma'am, I also have a appointment tomorrow at 12 noon. Can I take the exam around 11?
No, I cannot release the password before. It is a password dependent, right?
We can start at 11. All of us.
Everyone, you just decide, dear. Don't ask me.
If
You guys are
anyone
taking,
agrees,
yeah. So you guys decide, and then I am going to be there. I'm going to give you the password and do that. But I cannot release the password one by one. You understand that, right?
Miss,
Yeah.
what
So
if
every day somebody will have some problem, right? So you have
yeah,
to decide what is the something, and we have to accommodate with everyone's problem. So you guys decide. So it's going to be 47 questions and 60 minutes. Okay.
we can start at 11. I'm fine with it.
Yes, please. Thank you.
Yes, mom, 11 is fine.
Everybody, 11 is fine. So tomorrow I am going to send the review. When I'm done, I'm going to send it. Your exam is starting at 11. Okay.
Okay,
But
thank
you
you,
are
ma'am.
okay. But after the exam, you are going to be stay. Just log on the team. You don't have to stay. Stay means on the computer stay. But you can do whatever. But you can close it at 1 to log out. Okay.
Thank
Okay,
you.
ma'am.
Okay,
Okay.
mom.
So we are
Appreciate you,
taking
ma'am.
the
Thank
exam at
you.
11. Yeah, because
Thank you.
Yeah.
I have some restrictions also, right? I cannot release one by one to password for everyone, right? So you
Yes, ma'am.
understand that. Otherwise, I try to cooperate with everyone, whatever is the problem. But whatever I am handicapped with the organization, I cannot break the rule, right?
Yeah, true.
Oh, okay. Okay, no problem. Okay.
Thank you,
Yeah.
mom. Thank you for that.
Mhm. I will send it as soon as I am
Today.
done.
Today.
Even not tonight, it may be in the daytime, whatever. I am working on that. Okay, now I like to stop talking to you guys because I need to concentrate on the review. Please excuse me and thank you. Otherwise, I will make a mistake. Okay. Thank you. Yeah, yeah.
Thank you, ma'am.
Okay. Concentrate on your study. No thanks. I need the good marks. Hmm, dear. Open stuff. Inward.
Ano, that is just more than every picture. They don't go so maybe good power to
Is that Amina? Your microphone is on?
What about the 50? Another thing old land.
Who is that? Rugiator? Whose microphone is on?
Yeah. You know my house.
Okay. Someone microphone is on.
Oh no!
It's 1 o'clock, guys. See you tomorrow. Keep studying. Good luck.
Yeah, thank you. See you tomorrow.
Bye-bye. See you
Bye.
tomorrow.
Yes,
Bye.
ma'am. Thank you.
We're gonna
Bye.
wait.
Bye, everyone.
I know, I
Bye.
know. I am working on it. It will take a little
Thank
bit
you,
time.
ma'am.
Okay.
Thank
Okay.
you,
We're
Mom.
Okay.
waiting.
Bye. 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 Bye.
Thank you.
Bye.
Bye.